Hello, my name is Casey Delaney, and this is my project for EE314 class. On the breadboard here, I've made a couple circuits. I've made a low-pass passive filter using a 7041 chip and several components that I will show on the board here in a minute, the whiteboard. I've also built a very simple band pass filter using inductor capacitors and resistors that I'll show also. You can use this as a high pass, a low pass, or a band pass depending on where we take the signal from. Right? So for the first part of the circuit, on my passive filter, a passive filter actually uses a 741 chip that has to be powered up with external power for the circuit to work. For the active filter. For the passive filter, I don't need an external source, just the voltage from the signal that's going through the source. All right? I have a simple signal going in using a power supply. I've tied my channel A input as my positive 15 volts going in to power my chip. Channel B is a negative 15 volts going in to power my chip. And I've tied the A and B together, which is my negative point. And I have a negative point, which is my reference point on my board also. I'm also using a simple function generator to inject a signal into my circuit. This is what gets injected into the circuit and fed through, which gives my circuit characteristics. And then I'm using an oscilloscope, single channel. I'm only using channel 1 to actually read my signals on. Okay. So for my first circuit is my active circuit. I have the power coming in here to my circuit, which feeds through. It's fed in through here through a couple resistors, which reduces the signal a little bit, through my 741 chip, and then back out on the high side here. All right. This is a low-pass, two-pole filter, Butterworth filter. On the scope here, we can see we have about 7 hertz coming out currently. So as I increase my frequency, you can see that I have a good band pass. I set up a 10-volt signal coming in on my circuit currently. As I increase my frequency, my 10 volts stays pretty constant until I actually hit the cutoff point. For this circuit, I figured the cutoff point's about 1.5K. So as my frequency increases across the range, so my frequency, I have a good 10-volt signal going across. As I increase my frequency, as my frequency gets higher, the amplitude of my signal is going to decrease. When the amplitude of the signal decreases to about 70.7% of the 10-volt signal, that's my cutoff point for my low-pass filter. So I'm going to increase the frequency until I hit about 7.7 volts peak to peak on my signal. Right about here, I got about 7.07%, 70% of my input signal, and you can see when my frequency has dropped. My frequency is reading about 1.36, 1.4 kilohertz, so that would be my cutoff for the low-pass filter. As my frequency increases farther, the signal gets drastically reduced. That's my low-pass filter. All right. My next filter, I'm going to take the circuit and I'm going to inject a signal into my passive filter, which is my band pass filter. Right? With the band pass filter, we usually read the output signal across the resistor. Once again, I set up mid-range for about a 10-volt signal. With the band pass filter, I pass low frequencies and high frequencies. For my circuit here, I'm going to start decreasing the frequency. Actually, hold on. We'll set up for the 10-volt signal coming across. That's my reference signal. As you can see, as my frequency increases and decreases, the voltage doesn't change a whole lot. As I decrease my frequency, though, my signal is going to start to decrease. Right. Once it decreases, once you get into 70.7% of the 10-volt signal, that's my low cutoff signal. And down to about 200 hertz, 120 hertz. Okay, my generator is messed up. I had to give me a different rehook on my generator. So right now I'm at my mid band. I'm going to decrease my frequency going across my circuit. Go back. My circuit's hooked up. So as I decrease the frequency, I'm looking for about a 7.07 volts on the input right here, peak to peak. You can see as the frequency is decreasing, my power is dropping. Once I hit about 7.07 volts, I'm at my low cutoff. So right about there is my low cutoff frequency, about 2.3 kilohertz. Likewise, as I increase the frequency, it's going to go back to the 10 volt reference. As I increase farther across that, my voltage will actually start to decrease. So now I'm on my high end for my upper cutoff frequency, and my voltage is starting to drop again. Once I hit about 7.07 volts, that's my cutoff frequency. So right about there, someplace is my high cutoff, about 1.4 kilohertz. So 1.4 megahertz. So my upper cutoff was about 1.4 megahertz. My lower was down a couple kilohertz. All right. On the board here, this is my simple bandpass filter that I had set up. When I take the output from the output here, it works as a bandpass filter. As I increase and decrease the frequency, my signal will drop off. So at low frequencies, it's going to block the signal. It'll pass a certain band and then block the high frequencies again. So it passes a certain band of frequencies called a band pass. Right. If I happen to take my output across the capacitor, it actually works as a low pass filter. Because a capacitor blocks low frequencies, I'll drop a large voltage across here, and the output's going to be like a low pass filter, pass low, block high. Likewise, if I take it across an inductor, which passes low frequencies and blocks the high frequencies, he'll drop voltage at high frequencies. So if I take my output across here, it's going to work like a high pass filter. It'll block the low frequencies, pass the high. Right? This is my Butterworth filter, my low pass Butterworth filter that I built. I have my input coming here to my 741 chip. It's a 2-pole. Each resistor capacitive pair makes a simple pole. So I have one resistor capacitive pair, a second one here on my input, makes a 2-pole circuit. I got my negative and positive 15 volts bleeding on my circuit. I got my output signal here coming across here with my feedback loops. This is a low pass Butterworth filter. Each filter gives me about 20 dB roll off. So this filter will drop past the low frequency in the output, block the high. And the roll off rate is going to be about 40 dB per decade. All right. This is also the formula you can use to find the cutoff frequency for your simple RC circuits. And these are pi filter circuits that I was experimenting with earlier, using simple inductors and capacitors. This is set up as a high pass pi filter and a low pass pi filter. So depending on what kind of a circuit you want, you can use a passive filter like this over here. Doesn't use any power, and just a signal coming in is what powers the circuit to give you a signal. Over here, an active circuit usually has like amplifiers in it, which requires an external power supply to power the unit up. And that is my project.